You all should have in front of you page 137. Again, we're going to be dealing with the factor 4 today. Let's take a look at the question in bold print. Jenna is making a quilt. She cuts fabric squares and decides to make the quilt with 5 rows of squares. Each row will have 4 squares. How many fabric squares will she need to make the quilt? Again, friends, close reading is very, very important here. I know that I am going to have 5 rows. I know that each row is going to have 4 squares. I am trying to figure out how many fabric squares in all. So could you draw an array? Yes, you could. Are we going to be taking a look at that on page 138? Yes, we are. Is there a way to break it apart? Yes, there is. Again, in remembering that target of breaking apart the factor 4, all right, there are a number of ways, number of things that you could draw on. You could use binder paper, whiteboard, scratch paper, your textbook. But what I also have to work with is grid paper. Remember, we've talked a lot about grid paper. You can use that too. The grid paper is the one, of course, that has all the squares. It looks like my chart paper that I use a lot. You can use that too, if that helps you. All right. So what I want to do is I want to take a look at page 138 so that we can walk through the steps of this particular problem. So I'm going to go ahead. What you are seeing on page 138 is the array that was built for that question on page 137. And you can see where my cursor is bouncing right here. So again, Jenna's making a quilt. She cuts fabric squares and decides to make the quilt with 5 rows of squares. Each row will have 4 squares. How many fabric squares in all? This is what we are trying to find out. So you will see, friends, again, the rows, 1, 2, 3, 4, 5. 5 rows, and you will see 1, 2, 3, 4 squares in each row. Again, going back to that target of breaking apart the 4, take a look at the array to the right. You will notice that the numbers, rows and columns are exactly the same, but you can see that dividing red line is breaking up that 4 into 2 and 2. All right, so what was 5 times 4 is now 5 times 2 plus 5 times 2. We've simply broken apart the 4 into 2 and 2. Now the model below it is what we've been talking about when we take those arrays and we flip them back and forth. You will see that this first array is 5 times 4. When you flip it, it becomes 4 times 5. You will notice on this array that the number that we are dealing with does not change. It does not change. We've simply taken the array and we've tipped it. So we started with, for example, if you can see in my screen, I know it's kind of small right now, we started with the original 5 times 4. And then it just got tipped over. You can think of it as someone took the array and gave it a nudge and just tipped it on its side. So now, instead of 5 times 4, we are looking at 4, where my cursor's bouncing, times 5. Again, we went from 5 times 4 to 4 times 5. The amount is the same. It's just we've flipped the factors. And remember, we called that the commutative property of multiplication, which says you can take the factors and flip them around. The product will remain the same. 5 times 4, of course, is 20. 4 times 5 is 20. The big idea here, friends, is that the amount does not change. We've simply flipped the factors around. Thumbs up if that makes sense to everyone, and if you're seeing it. So far, so good? Good. All right, so if you take a look at page 139, which is where I'm scrolling now, you will see that these questions are a lot of what I've just talked about. So if you take a look at number 1, it says to look at the 2 smaller arrays in the first modellet. What 2 facts are shown by the smaller arrays? So again, going back to it, we start with 5 times 4, and then we end up with 5 times 2 plus 5 times 2. Okay, 5 times 4 equals 5 times 2 plus 5 times 2. The first product, 5 times 2 is 10. The second product, 5 times 2 is 10. Of course, that total is 20. Okay, now if we go back and take a look at that second modellet here, where I've taken that array and I've just kind of nudged it and I've pushed it on its side. The question is asking you here where my cursor is bouncing on number 3. It says to look at that second modellet. What's the new multiplication expression created by turning the array? And of course, it is now 4 times 5, which is supporting the commutative property of multiplication. Okay. All right. So now, friends, if you take a look at page 140, if you take a look at page 140, up at the top where it says apply it in green, show how to find the product of 3 times 4 by breaking apart the problem and also by changing the order of the factors. Show your work. All right, friends. So yes, I would like you to work on this problem right now. I would like you to work on this problem right now. I'm going to give you a couple of minutes. Again, show how to find the product of 3 times 4 by breaking apart the problem. Remember, friends, our learning target, you are breaking up the 4 today. You are breaking up the 4. And also by changing the order of the factors. And again, what are we meaning by that? The commutative property, where we're going to flip the 3 times 4, and then we're going to make it 4 times 3. It's asking you to show your work. And of course, by that, we mean to model it. We'd like you to model that using arrays. So you were asked to show how to find the product of 3 times 4. So that is definitely where I am going to start. So what I'm going to do, and hopefully this will work for me. So if I take 3 rows, and then of course there are going to be 4 in each row. And I'm sorry, this annotation tool is a little bit slow, but it's much clearer than the iPad right now. All right, so that is going to be messy as it may be, but this is what an array of 3 by 4 would look like. But it's also asking us to use the break apart strategy. And of course, that learning target, we are breaking apart our 4 today. So in doing that, I would be doing what? I would be breaking apart those columns, because it is the columns that are represented by that 4. So I end up with something that looks a little bit different. So instead of a 3 by 4, I end up with a 3 by 2 and a 3 by 2. Does everyone see that? Breaking apart the 4. And then we also were asked to take that array and tip it on its side. And when we do that, we end up with not 3 rows, but we end up with 4. And again, very slow, messy annotation tool, but I definitely want to show you what is happening here. All right? So when we take this original 3 by 4 array and we tip it, we now end up with 4 rows and 3 columns. So what was a 3 by 4 is now a 4 by 3. And again, friends, that supports the commutative property of multiplication. We can flip those factors. The product doesn't change. And that is exactly the point here. All right?